Anderson sir, you should, please share the screen which you want to be seen in the YouTube, basically. So,
Yeah,
the thing is that this Discord call will be shown on the YouTube screen. So we should share this screen which we want to be in YouTube, basically, whatever you're doing. Or you want to talk, you can share your face also, it's fine. But it
yeah.
should
Let
be
me try.
what you want to show.
Please let me know if you guys can see it correctly.
Okay.
Hello guys.
Yeah, we can see your screen. Plato, you're in?
Yeah, perfect. Do you guys see like a glitch page, right? The website, the
Yes,
glitch website.
yes, yes, yes.
Perfect. So it is working.
Yeah, I think we are live now. So, GM everyone, we have been joined with Anderson Mancini, who is the CTO of Neotix. We have been joined with Plato, who is the office dev. Nar, who is a web chat now finally, and he's an independent coder and learner of Three.js. And we will be joined with Evan Trotsky, who is streaming now, and he is the WebOS dev. Welcome everyone. We should start this stream, and let's discuss about the Three.js stuff.
Perfect, perfect. So can we start this? Like, or should we wait a little bit more?
No, I think we are good. We're live now.
Great, great. So thank you for the invitation and welcome everybody. My name is Anderson Mancini. I'm from Brazil. I'm 42 years old, and I will show you guys a little bit of the Three.js background, how we can create very basic scenes, how can we set up the project, and how can we start with this thing. Like Three.js came into my life in a more serious way, I would say, last year, because I was trying to find someone to hire to do this kind of stuff, but I could not find anyone, or everybody was like too busy to like help me. Though I started the Bruno Simon course, the Three.js journey, which is amazing. I highly recommend you guys check if you don't know it yet. And then I started doing this kind of stuff, Three.js related projects, because I'm mainly a designer, not a developer, but I had this background in development from the past years that I used work with development. So I gave it a chance, and it looks frightening when you look at the first time. But as you learn more about it and you get used to it, I would say like any language or any library, things get more and more easy to learn. And what I will present to you guys today will be this kind of step by step how I do stuff and what I use to do this kind of stuff. And I will also like apologize for my not so good English. I for sure do a lot of like English grammar mistakes because it's not my mother language, but I will try my best. So, one thing that I want to jump into is like the tool that I will be using to show you guys what I usually do and why I use this. Like, I would say the entrance point for anyone that is not a developer to join this world would be to find a development tool. And this for me was hard because I was not aware of npm and installs and running things on my computer and had to deal with the command line like things. That one was frightening at the beginning. I learned, but in the end, like today, I usually use this kind of tool like Code Sandbox or Glitch. Like Glitch is awesome because you can do your projects. It is free to code and you can see the code and the changes like in a real time. So it is awesome to work with this kind of thing. So all you have to do is create an account. This is the screen that you see at the first place. then you hit new project and you are ready to go. Like that simple. Because I already have some things that I want to show you guys, and because we have a short amount of time here, I will open that a project that I already have. But just to show you guys what happens when you hit new project, you can choose like a bunch of different type of projects like React and like everything. So you can choose a very basic one, like you have even more here, like a basic website. This is the one that I usually use, like is a blank version. So I hit here, and then it will create a new project for you to work with. And as you can see, you have the code on the left and the preview on the right. So it is there. You have an index, a script file, and a CSS file. All that you need to start coding. So what I use is the one that I already have, because I want to show you guys how can you implement Three.js projects. So let's open this. And instead of typing everything and passing through every step and mistakes that I usually do when I'm typing, I will show you guys how to set up the project, and then I will go like block by block describing what is doing and what is used for. And in the end, we get this result here, but we will improve it a little bit. But like to be able to get something like this, as you can click and drag and see a 3D model, it is very simple. It is not that difficult. So let's start this. So here, like in the index.html, we have like a very simple HTML file. And the only important things here, like are those lines here, like where we insert a script to be able to deal with the ES modules on a browser without having to build the project and anything like this. This, by the way, is on the Three.js documentation. This is the way they recommend to use this. Then you have another script to add the import for the Three.js module. So you can work with modules on your browser and import like statements from and libraries from the script file. And then finally, we have the script files. So it's that simple. The everything that is running here on HTML side, it is running inside this script.js file, and it is responsible for all that you can see here. And what we have in this file, like we have the Three.js file, like the Three.js project structure. So I will pass through it so we can see what is happening here line by line. So it is a pretty basic one, but in a sense that we have a model like already in the scene and we have shadows. So it is not that basic because we are not like creating a cube or a sphere. That it is good, but usually you want to work with a loaded model, not with the cube or spheres or anything like that. So that's why I'm showing how to import models already made for someone else, from someone else. And then in the end, we will see how can we replace this model, how can we find models, how can we do different stuff using Three.js. So the first thing, we need to import Three.js, like this is the first thing we need to do. Then we need to import the libraries that the additional libraries, the additional files we will use on each specific case. So in this case here, this is all that we need. Like I'm importing the orbit controls. This one is responsible for dragging and dropping and enable this kind of interaction. You have a lot of other options to use, like mouse controls or keyboard controls and many more. You can check on the documentation for Three.js. Then I'm using GLTF loader. This is the name of the file format that I'm using to import that specific model. So you also have a lot of different model support for FBX, for OBJ, and many others. So I'm importing this specific one because this is the one that I'm using here. Then I'm importing twin just to be able to create this animation. Like when the scene starts, it animates the camera. Like I guess it is a little bit glitchy because I'm sharing my screen, but I hope you guys can see it. Then I'm importing Draco Loader. Like Draco Loader is one thing that enables you to load compressed models. This is the type of the compression format for 3D models on the web. So it is not mandatory, at least if you have a compressed model, which is my case here. So you can also check the documentation because they have a bunch of other formats that it's supported, and Draco Loader is not always needed. And then we have the RGB loader that I will be using to create this environment that we can see as a reflection. Like this reflection comes from a image faking an environment. I'm using it through this RGB loader. So this is the imports like that we need for this very basic scene that can load models. Then we need some definitions for the Draco loader. I will not go too much in details on this because most of the times I just copy and paste and it works. Like it is that simple. It's all that you have to do is to define like a loader to be able to use that class that we are importing. Then I'm setting the decoder path for the Draco loader, and then I'm defining that the loader we will be using Draco loader. So it is kind of a setup to be able to use Draco loader, but we are not loading the model yet. So this is a first step. Then after this, what we have to do is to create a container. So in our case here, like I'm creating a container on runtime. You can define a container on your HTML document as a div and then reference to that div to be the container of the scene. In my case here, I'm creating this pretty simple div on the HTML. And then I'm saying like that this container will add a class Three.js just because I want to play with the CSS part on this div. So I'm attaching a class on that div, which is by the value to mention, this just disabling the pointer events. So the CSS is nothing, like we don't have anything there. So, and then finally comes the Three.js part of it, like the creation. And for a Three.js project, there are some things that are important. And to understand the order, it's also important. So the first thing we need, like it is a scene. Like in a real life, if you want to shoot someone like playing or someone like doing something, you need a scene, you need an ambient to be able to put cameras and to put lights and insert things there. So the scene is the one thing that will be rendered by the camera. So the scene is the one thing that you create like a stage to be able to place things inside. So first thing we create the scene, then we define the renderer. The renderer would be the type of film we will use into the camera. So all of those parameters here are creating a renderer. And the renderer is just like a WebGL renderer. And we pass some parameters like alias and the kind of performance we want to have if the user has, for example, two different graphic cards on the computer. I'm setting up that I want to use the highest one, the powerful one, because we are dealing with Three.js stuff, so we will need the powerful one. But all of this is optional. It is not like mandatory. Then we set up the pixel ratio to be able to control how much pixels we want to render, like based on the screen resolution from the user. Sometimes people use like a very high resolution monitor. So I kind of clamp the limit. So I don't want to use all the resolution they have available on their monitor, but I'm clamping it to the maximum of 2. This gives me a lot of like better performance usually on my projects. And then like we are also set up in like some parameters for color encoding and tone mapping and exposure and a bunch of other stuff just to create the renderer. So for example, if I turn like this value here for exposure to 3, you guys will see like in real time, it is way more exposed here. So every color on the environment, the scene that the renderer is rendering, it is now more like it is brighter because of these parameters. So you also have a lot of other parameters, so I will not pass through all of them because otherwise this will be a course and not a talk. But it is like just show the order. Like it's also on the renderer that you set up, for example, the shadows. Like I'm enabling shadows here just to get that shadow on the floor. So if you disable it, by default, it is disabled. So you don't have shadows, but also enable and you choose the type of shadow, then you can have shadows. And I will show you guys how to set up the shadow in other places because it is not just enabling shadows. But then after you create the renderer, what we are doing is appending that renderer into the container that we created here. So we have the scene, we have the renderer, and now we are attaching the renderer to that container. And this is the magic that happens. Like the Three.js will create this canvas through this renderer. So the result of this class here is a canvas. So this canvas it will be attached, appended to the container that we created here, or that we referenced in our divs on the HTML. And that's it. So with this, we already have a Three.js scene, but there is nothing to see. So if I try to render only here at this point, we will have some result, but with nothing inside. So now it is the time that we make things in, like create things inside that scenario that we created, that scene that we created. So the first thing, we need to have a camera. Like we need to have something to be able to record the scene that we created. So, and we can also pass some parameters. All of those parameters you can see on the documentation. So it is basically like the field of view. So if I like, for example, decrease this number, you see a much closer camera because the field of view is so tight that you cannot see the entire picture, like in a real camera. And if I increase this like to 75, for example, you can also have a wider angle. So it is kind of the same thing that we have in our real lives. So I'll just go back to the default. And then we pass the aspect ratio for the scene that we have, and then how much closer this will see the object and how much far it will see. So for example, if I place it here like 3, probably we will see nothing, like you guys can see, because the camera is not seeing far enough. So there is maybe a magic number here that our object is placed. And as you guys can see, the camera now can see only until the 10th step of the camera. So it is 10 steps away from the viewer. In this case, the viewer is the camera. So this number might be changed depending on the size of your scene. If you have a huge like city and you need to see far away, like in a game, you need to increase those numbers. But by default, they work usually. And then every time you create something, it is not just like create something and it is done. You need to tell Three.js that you want to add this to that scene. And why? Because you can have multiple scenes on Three.js. So you can have like a one scene that you are rendering like a player, and in another scene you are rendering the background. And then you can use post-processing to compose this kind of thing, or to make a transition between them, or to make a portal like a game when you can see something from the second scene on the first one. So that's why it is important every time you create a camera or anything, you need to add that thing, that object inside the scene that we created. Here is pretty basic JavaScript. All I'm doing, like it is creating the resize, so we can get all the time a full screen experience. So that's why when I resize, this thing keeps running and keep resizing. So it is just pretty basic JavaScript. But with that parameters, we set the camera, we update the camera projection, and then we set the renderer, and we set again the pixel ratio. So all of those parameters here, they are here when we created the renderer, but as the user scales the screen, if we want to have this in a full screen experience, we need to tell again the new parameters, and this is what this code is doing. And then here we are creating the orbit controls. Like, again, it is not mandatory, like not every time we need like orbit controls, but in this case, I'm using to give the user the ability to click and drag and to see things in real time and to rotate around this. So that this is what it's doing. Like, we are creating the controls, we are passing through the controls, the camera and the renderer. Those are the two objects that this class needs to create the orbit controls. And then we have only a setup to make it a little bit above the ground, because otherwise it will look directly to the 0, 0, 0 of the scene. And in my case here, I made it look like upper. So for example, if I do it like 9, as you guys can see here, now it is looking like from behind. So this here controls like where the camera will be looking at. So the camera always look for the control target position from the orbit controls. And why? Because if you right click and drag, you can see it from another point of view. So you are moving, in this case, not the camera, but you are moving that object that controls target to be able to see from another point of view. But when you click and drag, you are moving the camera. So this is the tricky. The camera is made on two parts. One is the camera and one is the target for orbit control. So this is when you drag the camera, and this happens when you drag with your right click. And then you can also disable, like this class here has a lot of options to enable auto rotate and many other things that are very good to work with. Then after this, like we finally load the model, and we do it by like I'm just creating an empty variable to place the model inside, because in the next class, like in the next step, we will make this rotating, like we'll make this rotate around itself. So that's why I'm creating this here. And then this loader comes from the loader that we defined here at the beginning, and I'm saying through Three.js. So please use that loader to load a model, and this is where the model is. And how we do it, how can we use like imported models? So all we have to do is go to the assets folder here, and we have like models here. Those are in the GLB format. GLB format is the most common one to use because it encapsulates everything. The textures, the animations, the meshes, everything is one piece. It is easier to work with. You have a lot of other options like GLTF and other stuff, FBX, but with them you need to load textures separately usually. So I usually use GLB files. And where you can find GLB files? Well, there's a bunch of places. I usually use Sketchfab, or I create my own. Like for my specific projects, I create my own models, and then I import and export into the GLB format. So for example, if you want to use this beautiful frog here, like all you have to do, by the way, giving credits, this is the creator, like the Kaimuri. I hope I pronounced it right. So all you have to do is to download the model. I already downloaded it, and then you can only drag and drop the file here, like inside the assets folder for the glitch. And the beauty of it is because it is CDN based. So to use, all you have to do is to click on this model, and then you have the CDN URL here. So you copy the URL, and then on our loader, all we have to do is to like give another model here. So we will use this in the next step here. Like our model is there, but it's tiny, and then we will see how can we increase the size, but whatever. just to show you guys how simple it is to actually load a model. So I'm loading this one from the same place. This model is here, this Three.js logo here. Okay, and then this will return a function. Like we need to get that result from the loaded model, and once it is done, we will give it a function with the file that we actually loaded. And then here we are adding that result inside the scene. Like we said, every time we want to add something to the Three.js, we need this scene.add and then the name of the thing that we want to add. In this specific case, is the result from that file here. So you can also like console.log this one here to see the results that you get from the loader, but it is like a object with a structure of a 3D model. Let me console log this very quickly so you guys can at a little take a look. And let me see if I can open this console log here. Yeah, so as you guys can see, like the result for this console log, it is a group. And inside the group, I have a bunch of stuff. This is not Three.js related. This is the way that a GLB file is created when you export in this format. So it is a JavaScript kind of object. And inside that group, you have a mesh. And inside the mesh, you have other objects and other properties that this is the one that Three.js uses to create what we see on the screen. So this is the way it works. So let's continue. I just comment out this line. And then here, what I'm doing, like remember that I said for enabling shadows, you don't only say like, please add lights and shadow and it is done. Every object for performance, when you load, it doesn't come with the cast shadow and receive shadows enabled. So what I'm doing here, I'm traversing the model, and traverse is the name of the thing that you use to pass through every child on that object that I showed you to find things. So I'm saying go into that object that I loaded recursively to find things and to do things that I want. This is what traverse is doing. And I'm using this method to get the object from, like, to get the object information. And on each object, I'm checking if it is a mesh. Because if I try to do this like here, it will not work and probably will give me an error and anything, because you can only enable cast and receive shadows on meshes, on objects that are actually meshes. And sometimes in some scenes, in some objects that you import, you have more than objects, you have more than meshes, you have lights, you have cameras, and lights and cameras cannot support cast shadow and receive shadow. So that's why we are traversing the object that we loaded to find meshes, and in all the meshes I want to enable. Like if I don't do this, if I comment out this line, as you guys can see, we don't have shadows anymore. So we have light, we have the renderer, we have the renderer being set up to render like with shadow, but because the object is not shadow enabled, we can't see any shadows. So, but it is that simple. You just enable shadows on all the objects. Then here, like we are doing just a very basic animation. So just to have that movement. And this one is tricky because every time people ask me, how can you create, like, for example, Windland, like the project that I usually share. And it was my first project that animates the camera. Like if you guys never saw it, let me show it here very quickly. Yeah, it is this one. Oh my God, here. I hope I don't crash, but sometimes because of my external like GPU, sometimes I crash when I open multiple instances of Three.js. Can you guys still hear me?
Yes.
Yep, you're good.
Yeah, so just give me some seconds because my computer needs to like recover.
No problem.
Yeah, it's fine.
Yeah, that's here. We are here back. So can you guys see my screen, right?
Yep.
Great. So like this camera animation that we can see here, like what is happening here, like this camera panning kind of movement, it is done with the same technique that I'm using there. So I'm using a twin animation. And how it is done, let me just close this one here. Like we create a new twin. By the way, the twin, it is inserted inside Three.js. So the beauty of, like you can use other stuff to animate like GSAP and many others like React Motion, Framer Motion and anything, but I use Twin because it is inside Three.js itself. So as you guys can see here, we import this from the Three.js library. So we already have it in there. So I just import this. And we are creating a new animation and we are setting a camera position by default to be away from the object. That's what this is doing, because by default the camera comes in the 0, 0, 0 of the scene. So every time you create a camera, it will be placed in the middle of the scene as the object. So usually your camera is inside the object. Everything is on the same place. So what I'm doing here, I'm just saying make the camera away from the object so I can animate towards the object. And then I send another position and it has a vector of positions. And those are the positions that the camera lands after the animation. Then we have the duration. Like if I increase this duration here, for example, 8 seconds, this is the time that the camera will take to travel to that position. That's simple. So you can control the easing and anything and many other stuff. And then I'm telling just to start the animation. But there's an important thing when you animate the camera. You can also animate the target because otherwise the camera will be animating. Remember that I said the camera is like made of two parts. If you animate the camera, but you not animate the target, the camera will be always looking to that place. And sometimes you need to animate both at the same time. So this is what I'm doing here. I'm animating the camera and the target position at the same time. So let's continue. By the way, like it is not all of that I'm creating here is mandatory for a Three.js scene. Like for a basic scene that doesn't animate and things like that, you don't need that much stuff. I'm just passing through all that we have here because we can use this as a setup scene to build our own, your own projects. But for sure, this animation is not mandatory to have. And we will see another scene that we don't have a camera animation, and it also works fine. So then continuing to the Three.js, another thing that we need to have is a light. Because if you don't have a light, like if I remove the light from the scene, we will see probably the object because we have the environment. But as you guys can see, I don't have shadows. And if I don't have the environment, I would see nothing because I'm like, imagine a room without light. You insert things there, but nothing is visible to the camera. So lighting is usually important to have at least, like if you don't have like an environment like we have here. I will show you guys what I mean by the environment, but a light is important to have on a Three.js scene. And then I set a bunch of parameters for light to have the shadows. So you need to enable shadows in Three.js on three parts: on the renderer itself, on the objects to enable receive or cast shadows, and also on the light. So the light it is not enabled by default to cast shadows for performance reasons. So you need to enable them like manually. But those are the parameters that also default on Three.js documentation. You can copy and paste from there. And then we are creating the floor. So the floor is the one thing that is receiving shadows here. Like I would just change the material because I imported the model, but the floor I'm creating on Three.js side. So just for us to see what is happening, mesh basic material. So this is creating a floor, as you guys can see, like a black floor, like a black something to place objects on it. And to create objects on Three.js, if you don't have, like, I could import even the floor from the 3D model. I can edit this model on Blender or Cinema 4D or whatever, and place a plane under it to act like a floor. But if you want to make things on Three.js, you can also create models using it. So what we do, we create a geometry, like a geometry to have this format. You can create planes, you can create spheres, you can create cubes and many other geometries by default on Three.js. Then we create a material because every mesh needs to have those two parameters. And then we create like the final mesh that will be added to the scene. And this Three.js mesh is composed by a geometry and a material. And in this specific case here, I'm using this special kind of material because this one can only render shadows on it, which is awesome because we can have this transparent, infinite background, but we have a plane actually there that is receiving shadows, like we can see here. And we can control the opacity, for example, for this shadow. I'm making it not so dark, but you can make it darker, for example, if you want, without having to increase or decrease the intensity of the shadow and the color of the light or intensity of the light. I could do it, like for example, if I increase here for 3, the intensity. And by the way, don't be afraid of all of those parameters, because once you have this name, like new 3.pointlight, you can reference to the Three.js documentation, and then you can see all the parameters that you can pass, what they are. For example, this one is the light, is the color for the light. So if I want to have another color, like a red one, I just change the parameter here, and also the intensity, and also how far the shadow will be. So you can see a bunch of other parameters on the documentation. But that's it. So here we are creating the plane. We are adding the plane to the scene. We are making it also to receive shadows. In this case, we don't need to cast shadows because we don't have any objects like under the plane, under the floor to be receiving shadows. So it is better for performance if we use shadows like in a very careful way. But usually Three.js is very good on handling shadows. And here I'm rotating the plane because by default, the plane will be added like in the middle of the object. As you guys can see, remember that I said that everything that we add into the scene, Three.js inserts in the middle of the scene. So this is what is happening here. We are seeing, actually it's looking pretty good, but it's not the thing that we want. So I'm just making, instead of this rotation, like the horizontal rotation, to have this object acting like a floor. And that's it. Then here we have the environment. And why? Because if we don't set up the environment, we will see nothing on that metallic object. So as you guys can see, like it is metallic, but it doesn't act like a metallic object because we don't have anything to see. And Three.js, it is not like by default rendering reflections all over the way. So you need to create an environment on the scene, on that room that we created, to tell to the object, look, we have an environment here. So this scene is not empty from the point of view of a background. We have a background. And this background, in my case here, it is also giving light because I'm using the RGB loader. The RGB loader, it is loading a ATR file, as you guys can see here. It also comes from the assets folder. It is here. So it is like a file that is an image that has like light information on it. So in this AGR format. And then what I'm doing here, I'm loading it like from this class, and the result of this loaded object will be a texture, and I'm using that texture first to correct the mapping. So I'm passing to this loader, look, I want this look like an environment. Don't load me as on a plane. I want this to be like on a global kind of environment. So this is what this line is doing. And again, here I'm setting this as an environment for our scene. I could also use this as a background. So if I do this, as you guys can see now, the reflections, and by the way, this is the result of the HDR file. So we see the reflections, and we also see the environment that the reflections are seeing. But because in this specific case, I want just the reflection, I get rid of the background. So we only have the texture to be rendered as an environment for the reflexive objects, which is awesome because we can also place another background and not using the same one as the objects are reflecting. And then I will jump this part for a little bit because we don't need to deal with this right now. I will show you guys what is doing here in the next file. So we can probably get rid of everything we see here because we are not using it anyway. Just to make it like easier to understand. And then finally, we load, like we create the render loop. So if we don't do this render loop here, like let's imagine that what we have the scene, we have the camera, we have the lights, and we have the objects. And then we need to render. But if I render only once, I will have just a screenshot of what this camera is seeing. So what those lines are doing here is to render it in loop, like every frame of the animation. This is what this method, and by the way, this is not Three.js related. This is JavaScript. So every time that you want something to be recursively running, you use this method, like request frame animation. And what it is doing, it is calling the same function forever, over and over again. And this function is updating the tween because we need this to see every update on our animation. We also update the controls because we want to have every frame the controls being able to see the new positions for the camera, and we are rendering the scene. And for the renderer to actually be seen by the camera, we need to pass two objects, the scene and the camera. So if I like comment out this line, we will see nothing. So the canvas is there, the Three.js is there, everything is there, but nothing is visible. So this is the crucial parameter that we need to have. We need to have this line to say to the JavaScript render, using the renderer, render the scene using the camera. So it is kind of verbose because we need to tell a lot of places that we need to render, but that's it. That's the way it works. And like with 150 lines almost, we have everything that we need for create this kind of stuff. And for a second step, just I want to show you guys a little bit more advanced stuff. By the way, I will just replace the file. So I have a bunch of files here. What I will have to do is to scripts underline 01. And now we have a different things to see. So it's the same file. It's the same thing that we did, but we added some things that are extra. And can you guys still hear me, right? Because sometimes my connection like goes not so bad, not so good. So just to check if you guys are there yet.
Yeah,
Yes.
yeah, we can hear. No problem.
Great, great. So to continue, then let's have a look what we have here. Like now we have the object rotating. What I'm doing, remember that I said that when I loaded the model, I created an object created a variable to receive the contents of the object. And this is what I'm doing here. I'm just saying to Three.js, like in fact to the JavaScript, place whatever is inside the mesh of the object inside this variable. And then all we have to do on the render loop is to say, I want to rotate that model with some increment or decrement. Like if I place it plus here, we will see rotating like in another direction and on that specific axis for the render to be in loop. So it's that simple. And one important thing that usually I see people try to do it and not being able to achieve, it is because they try to do it like here, like here. And what is happening, like it is giving me an error. That's why it is not rendering anything, because in the first frame, when the Three.js try to render and try to rotate this model is not ready. So it is not loaded yet. So we need to check if the model is already loaded, then we can rotate it. So this is the only thing that is happening here. I'm just checking the model exists already. If so, do the model rotation. And also the other thing that is happening here, which is cool, I will just comment out the rotation a little bit for you guys to see what is happening. As you guys, let me increase the intensity of this effect so you guys can see in a more easy way. So when I move it, like I have the camera kind of acting with an inertia kind of movement. So it follows my mouse, but it is with an inertia effect. And I can also drag and drop, like drag and rotate around this as my mouse follows the camera. How can we do it? We do it by doing those lines here. So first thing we need to have, like it is a code to be able to see the mouse position. This is pretty basic JavaScript, is not Three.js related, but what we are doing, we are creating a Three.js vector. Like this is a different type of variable. It is not a normal variable. It is a variable that can holds like three numbers, three contexts, three values. So this is vector 3. We are creating this variable to store the cursor position, like the X and the Y. We are not, in fact, using the vector 3. We could use vector 2, but whatever. It is storing everything that we map from the mouse position inside that cursor variable. And that cursor variable is holding the current mouse position. So let me console log this so you guys can understand what's happening here. So as I move my mouse here, as you guys can see, in real time, I can see on the console log the mouse position. So it is, this code is giving me the result from the center of the screen, and to the left, it will be minus 0.5, and to the right, plus 0.5. And the same for the vertical axis for the Y position. So this is giving me the current position of the mouse. And if I use this in our code that we see, you will see briefly after what is happening, I will get the camera moving exactly to the mouse position as I go to that position. But this is not what we want. We want this to be an inertia-like movement. So that's why it comes in place the lerped position. This lerped-like value will be done by the lerp function, and it will kind of create this inertia value. So if I place, let me do all two at the same time so you guys can see what is happening. I accidentally opened the terminal. So I will console log both values, the cursor position and the lerped cursor position, so you guys can see the difference. So as you guys can see on the console log, like the lerped value, it is taking time to reach the mouse position. So the mouse position is already like set up. It is the current value that my mouse is at, but the lerped position is making calculations to make the value reach the number that the current position is there. And that is creating this very beautiful camera movement. And the tricky part here is because we are not moving the camera, we are moving something else. So if you try to make the camera instead of this camera group, what we will have? We will have a fight between the orbit controls. This here is also updating recursively the camera position. So we don't want to mess up with that one. We want to have the camera controls to be able to rotate around the object, but I want at the same time this movement of the camera. And how this is happening? We are creating a group. So Three.js supports group. You can encapsulate things inside one another. So we are creating a group, an empty group, and then inside that group, you are putting the camera. So the camera is in the two places at the same time. It is on the scene, but it is inside the group. And we are moving the group here. We are setting the group to follow the lerped position of the mouse. And this is giving us this result here that we can see this camera movement. So it is another thing that you can do, so like using your knowledge from Three.js with JavaScript. So here is like the basics of the Three.js. I have another one that I want to show you very quickly. Please like give me some track of time because I'm completely lost on time. Like, are we like okay with time or we need to finish?
We're good, sir. Can
Perfect.
continue.
Okay. So as you guys can see here, now we are doing another thing, like adding up everything we did so far, we are doing post-processing. And post-processing, I would say, it is the one thing that makes everything on Three.js more interesting, because you can do more than just rendering normal stuff. Imagine like you have a Photoshop in 3D in real time. Like you can do everything that Three.js can do, but you can add a layer in front of it and process those images being rendered by the Three.js with a Photoshop-like tool for post-processing. And this is what post-processing is doing here. As you guys can see, we also have now this bloom effect and also some kind of grainy effect, like a film effect. And I'm rendering it black and white. So all of this is being created by the post-processing renderer. So how it is done, like we add some additional libraries that we need to use, like, and those come straightly from the Three.js documentation. If you search for Three.js post-processing, you have the documentation where they give those instructions how to do it. So you insert the new classes that you want to use. Specifically, you want to have two. You need to have the effect composer. This is the one that acts like a rendering pipeline. So you throw the images, the renderers on it, and it will create all the passes, all the layers of effects you want to have. You can add multiple effects at the same time, and all of them will be added to the effect composer. Then you need to have the render pass, because you have the renderer now being controlled by the effect composer. You need to tell the effect composer, look, I already have one image to give you, and this image is the result from my default renderer from Three.js. So like in a sense, you don't need to render the scene anymore. The scene will be rendered by the effect composer through the render pass. So this is what it is doing. And now the other things that you want to add, it's up to you. Like in my case here, I'm using film pass, and this one is responsible for the kind of grainy film effect that we have, and also the Unreal Bloom class, which is creating this bloom kind of explosion on the lights. And to set up this after you import, like I just gave you an example here. By the way, if you want to use this file is for you, like all you have to do is click on this remix button, and it will create a copy of this project for you on your glitch user, and then you have access to all the source code when you can play with them and everything. So what we are doing it here, like, is creating the post-processing. So the first thing we need to do is to use Effect Composer, passing the result of the renderer. So everything that the renderer was seeing before for the default Three.js render will be now inside this composer variable here. And then we need to create the first render pass. The first render pass needs to be the renderer itself, like the render that is being rendered by the Three.js scene right now. So this is the same thing as this one here. And as you guys can see, it's also commented, like I commented out this line, like we don't need this line anymore because the one that will be rendering is the composer. So we add this result of this inside this variable, and we add this as a pass. So we say to the composer, please add this as a layer. So the first layer of our post-processing pipeline will be the result of the current renderer. And then we add other effects. So I'm adding the film pass. I'm just instantiating it. And then I'm saying, also add this to the composer. And other thing, the bloom pass. So all of those parameters, by the way, you can also find on the Three.js documentation. They change a lot the look and feel for the scene. For example, if I place it like 3 here, this is, if I can remember right, yeah, this is the threshold. So the threshold is the limit of the light can explode or not explode. So if you increase this too much, it depends on a bunch of parameters. How much brighter is your scene? How much lights do you have in your scene? So many things can impact on those numbers. So you need to understand all those numbers, but they are all on the Three.js documentation. And then you can also add that to the composer. So by the way, if I comment this line, you can see the film effect, but we don't see the bloom effect anymore. So it is that simple. And then the only thing you have to do after adding your layers, you have to change your renderer. Like if I comment the composer.render, we will see the thing what we were seeing before. So no post-processing is being rendered. So when you add the composer, you make the composer be your renderer, because this line here, it is already happening from this line here. And that's it. And one last thing before we open to questions, two things in fact. Let me show another one that is just an example of this thing. I will probably freeze again. Yeah, I think so. Let me give another second for my computer to recover. But just to let me know if you guys can hear me. Yeah, okay. Like it is. Usually I don't get this type of hiccups on my computer, but using Three.js and sharing the screen at the same time, it is too much, I guess, for my poor Three.js, like my poor MacBook. So can you guys, I'm back, I guess, right? Can you guys see me, right? Okay, so let me try open it again. I really need another computer. Oh God, I guess I freeze, like it's freezed again.
Oh, this
So
does.
Yes, some more seconds, please. The good thing it is like it is capable of recovering it from it, but sometimes it is very annoying not
Yeah.
being able to show stuff like this. So I don't think I will be able to show you guys. But the third one, it is I'm showing how you guys can load another model. So I'm just replacing the model for another one, so you guys can see what is how it is done. Like it is a different scene. But unfortunately, because of my hiccups on my computer here, I will not be able to show you guys. But you can like see the link on the final project, press remix, and just replace the index.gm, the index script here for this one, and then you guys will see the results. One
Okay. And
last
then
thing that I want to show you guys is what you can do like other than rendering 3D objects with Three.js, which is very interesting. So for example, if you go to this one here, I hope I don't crash this time. Let's see. Yeah. So on this one here, like we are using Three.js, the same technique we were doing this one. As you guys can see, we have all the code at the same. We have less lines because we are not dealing with anything on 3D. We are using custom shaders. So all of those beautiful effects that you can see here is being rendered by a custom shader. And what a custom shader is a program that runs on your GPU instead of in your CPU. So we are giving instructions to the GPU itself to render images, to create graphics and this kind of thing. So in Three.js on this scene specific on this file, it is just being used to render it. So as you guys can see, the code, it is similar, but we have less code. So I'm just importing Three.js, just getting the container to be able to attach our scene here. And then I'm creating the same thing that we were creating, the renderer, the camera. I'm creating a plane to be visible to the camera. And that's the one that I'm rendering the custom shader on this plane. The only thing that we have on the 3D scene is this plane. So we have a camera and we have a plane only. We don't even have a light because on this scenario here, the type of the material that I'm using, this mesh shader material, we don't need to have lights. It is automatically visible to the camera because it has a light on, like on its own in this case. And then I'm rendering it, passing the shader and the information that we want. The real magic that is happening here, it is coming from this HTML part of the code. So we have everything that we have for a normal three like HTML file, and then we have these two things, that's fragment shader and this vertex shader. So those are two parts of the program that we need to give instructions for the GPU. But the beauty of this, like it is magical. So like, for example, if we play with the numbers here, you will see a completely different result. If we play, for example, with the amount of time that we take to update each frame, you have another kind of effect. So all the beautiful stuff that you can see on Three.js usually is attached to some kind of custom shader. It is not so easy to learn because you need to learn kind of another language. Like these shaders programs are developed in C language, not in JavaScript and anything. But the beauty of this is that you can have this type of effect with like no costs on file size. So to have something like this on a video, on a background for a page, for example, would take forever to load. So this one has almost no file size because it is a text-based effect. And I'm using this, for example. I will try to close this one before enter on another, and let's see if my computer can handle it this time. So let me just turn off the sounds. So like, I will crash again. Oh God, it is so frustrating to not being able to show things for you guys. But if you guys like see like this address, like this is just like a project that we just finished as at Neltix. This is a like car simulation wheel configurator for this industry, and you guys can see on the background like a custom shader that I'm using. Like it's a very good project to see. Like it's a very interactive. You can not only see the custom wheel, but you can also play with these and customize like your own. It's beautiful. Unfortunately, I can't show you guys because my computer can handle it. But I guess that's it. Like I hope this was helpful for you guys. That might help you in some way. And I'm open to questions if you guys have one or whatever. I'm here. Thank you very much.
Thank you, sir. It was very interesting. I was wondering, how do you manage when you have like performance issues, for instance, because I don't know if you build, for instance, I don't know what you build. I don't know if you build the websites or things or stuff like that. But when you
Yeah, so like you have many ways to fix problems on performance because it all depends on the kind of project that you are doing. But I would say the two most important parameters, at least the ones that makes a huge difference, is the pixel ratio. So let me try go back here to show you. So that will be this one here. Like the first one, I would say it is like all of them kind of lives in the renderer parameters, okay? So the first one is alias. Like imagine that you have a monitor that it is like a pixel ratio of 4 or 3. More or less, this is the amount of the pixel density that we have. But for example, on iMacs, on MacBooks, we have a even like higher pixel density ratio because of the Retina display. So if you turn on alias, like that will be huge on performance because you will have to render everything calculating also the alias. So usually I turn off the alias and I use post-processing to do the alias itself. So it would be better. But if you really need alias, you can enable it, but you should pay attention to this pixel ratio density. So by default, on the Three.js renderer, on the documentation, they say you to do like this. Like for they instruct you to set the pixel ratio to the amount of ratio that it is available on the user's display. So I always do this math, and I learned this from Bruno Simon on his course. So he
Mhm.
always instructs us to do like make a calculation between the maximum and get the maximum at 2. So if the monitor has like 4, get 2. If it has 3, get 2. In some monitors, you only have 1, so it will work whatever. So this is one important thing, another important thing. And the third one will be this one here, because when you don't set up the power performance for Three.js, it will assume that the machine will be capable of rendering it with the slowest, not so good GPU. So MacBooks, for example, they have two GPUs, one for normal stuff and one more powerful for 3D stuff. So you need to tell Three.js that you want to use this setting on the performance that mostly affects like Safari browsers and MacBooks. but on all the other machines that have more than one, they will use the most powerful one with the settings. But usually, those are the parameters that I play with: the pixel
Okay.
density radio, the alias, and the performance.
Okay, thank you. Very clear. Very clear, very clear.
Thank you. Like there is would be another thing that would be the mesh complexity, which is not our case here because our mesh is nothing. Like we don't have
Mm.
meshes there. It's very simple. But in more complex like objects, when you have, for example, an entire city, there's when it comes like a lot of techniques that you can use to reduce the complexity. For example, if you make the camera not see everything at the same time, you gain some performance. Like in games, like when you have a huge city, some games it is and some consoles are not able to render everything far away, so they clamp the limit of the camera. So that is the frustum culling from the camera, and you can control this by changing this parameter here. So you can change the frustum of the camera from 100 to 10 or make it 1000. It is up to your scene.
Mm.
Great.
Okay.
Someone else has another scout?
Yeah, I got a
Yeah,
question.
so yeah, go on.
So I looked at your Twitter and I noticed that you use R3F. I was
Yeah.
wondering, what are the advantages of that? I've heard there's some performance advantages, but I was curious about that.
Yeah, so like React Tree Fiber, like it is, I would say another taste on 3JS because it is more or less the same techniques, but the way you build that stuff, it is completely different. Like, and it's way much better and much faster and better for performance because you don't need to instantiate everything like in a very verbosy way, like we are doing here. Like we have a bunch of lines saying most of the time the same thing. So on React Tree Fiber, it is based on components. So instead of saying create the renderer, create the camera, create the scene, create the environment, render it to the HTML, all you have to do on a React Tree Fiber project, it is to say a component saying canvas. And inside the canvas, you place other components like a light component, a camera component, like instead the camera comes with the canvas component. So when you instantiate React Tree Fiber and you create the canvas component, everything that it is concerning the renderer, the scene, the camera, everything that you need to have a renderer ready to go, it is already made for you. So it is frightening how easy it is to create things using React Tree Fiber. I would say the difference, and especially for beginners, would be to know React. Because if you are used to React, React Tree Fiber would be easier to understand. But you would have to know some things about Three.js to be able to know how to use the components itself. So for example, when you create a camera yourself, you pass all of those parameters when you create the camera. When you do this kind of stuff using React Tree Fiber, you just place camera, and all of those parameters needs to be passed through the React as an argument. So you need to know how to deal with arguments on React. But if you are more familiar with React, I would say go with React Tree Fiber. Let me try to open a project here that it is on React Tree Fiber so you guys can see the difference. I hope I don't crash again, but let's see. Oh my God, this one will for sure will crash. I need to, because this one is so heavy. Okay, okay. I will not. Oh, like, I will not try to open. Let me explain, and then I try to open because maybe this will crash. But like as you guys can see here, using React Tree Fiber, I'm using in this specific case, I'm using also Three.js. So I'm using Three.js and React Tree Fiber at the same time. But what is happening here? as you guys can see, all we have like on the index is one component, the app. On the app component, we have like the canvas being rendered, and I have another component that I'm using, creating everything in one file. Is so not good example, but let me focus on what matters. Like in a normal, ideal environment, your Three.js scene is this one. So everything that we are doing here with 150 lines of code, it is being created in React Tree Fiber this way. So we don't have a renderer, we don't have a camera, we don't see those things here. Everything is inside the canvas. The canvas, it is the React Tree Fiber component that is creating all of that stuff. And then how we do orbit controls. We import orbit controls from Dray, which is a support library for React Tree Fiber. And then we use this as a component. So instead of saying all of those stuff we said here, import the orbit controls, then use the orbit controls here, then set the target. Everything is one line. How you change the color of the background? You just place a component for a color and attach this to the canvas background. And then it goes. My universe, for example, it is the one thing that is being rendered like on my scene. This is a React Tree Fiber component. So I'm creating a bunch of stuff here. I should do this in another file. That's why it's ugly. But you guys got the point. You define a component and then you instantiate that component on the canvas. So everything on those lines here is everything that we are doing here. So in this 150 lines of code. So it is beautiful. Let me try to open. If I crash, you guys already know it is because it is too heavy for my computer to handle. Yeah, I don't think it will run because I was in the middle of the development, but let me try to open another thing here. Yeah, this one. This one I recently created on, let me see. I don't crash. I don't think this will crash. It takes a while to run. Yeah, I can also don't, yeah. Whatever. I will have to take a look after because probably I messed up something and I changed something that I could not, but that I should not. Whatever, you guys got the point. Like it is easier to implement, it is easier to understand if you have knowledge on React. If you don't have knowledge on React, then I would say go for normal Three.js first, because in the end, you have to know Three.js stuff to be able to use React Tree Fiber. Not everything, because they are mostly auto-explainable, as you can read. But for some things, we will have to understand what is behind React Tree Fiber. So, for example, why you pass this position here for the camera. Like you need to understand that the camera originally, without React Tree Fiber, would be receiving 3 parameters for their position. So this kind of stuff. Sorry, I talked too much, so I hope I answered you.
That was a pretty good answer. I was also wondering, you used the built-in tween, but in the Bruno Simon videos, he used GSAP. Do you know why someone would use one versus the other?
I guess I freeze again. So let me try to stop my screen sharing so I can get any better. Yeah, let's try without the screen sharing. So do you mind if you repeat the question, please?
Yeah, you said he used the built-in tween, but in Three.js Journey, he uses GSAP. Do you know what the advantages of one versus the other is?
Yeah, like we don't have that much difference. I would say the GSAP it is more well documented, and you have more methods to deal with the animations. because like when you do Twin.js, like Twin.js, it is pretty simple. Like you have only pretty basic stuff to animate. So it is capable, but GSAP is more powerful. You have more options. For example, if you want to attach the animations on your scene, on your project to the scroll of your page, with GSAP you have scroll trigger. If you want smooth transitions between the scrolls, you have scroll smooth. So GSAP is more advanced doing animations, but the process I would say would be the same. The only difference is the options that you have using one library or another. I actually use GSAP a lot. I only use Twin.js when I don't want to add more extra things to the thing that I'm doing, because I already have Twin.js inside, so it is okay to use. But I use GSAP a lot. Anyone else with more questions?
Yeah, so the community is asking that when you have showed the landscape with a lot of trees and hills, you had problems with the performance. Is that a problem in broad environment too? This question is from Sibelius.
Okay, I think you are mentioning the Wineland, the one that I tried to show, but by my
Yes,
computer
yes,
died.
yes,
Yes,
exactly.
so I got a lot of problem performance on that one. And the first one was the amount of meshes, because I was lazy on that one. Like you have a lot of ways to optimize things on Three.js. So for example, when you have a scene with a lot of trees, you should go for instance meshed. So you have an additional library, an additional class on Three.js, which is responsible for instantiating meshes. So you give this one tree, and all the other trees will be created on the tree terrain by Three.js, which would be awesome. But the time I created the Wonderland project, I was not aware of that class, and I struggled with the performance. First, from the amount of meshes that I had. Also, I dealt with the meshes complexity by removing like all the things that you cannot see. So all the parts that are not visible for the freeze were removed from the meshes. So that gave me a little bit of more performance. Then I had to deal with the problem on post-processing, because on that specific project, I'm using like 3 or 4 different passes on post-processing. So I'm using kind of a global illumination. I'm using Unreal Bloom Pass. I'm using depth of field on real time with autofocus. So all of that, I would say the problem when you use post-processing, it is the amount of things that you do at the same time. Because like in a real world Photoshop, as you add layers, your files get bigger and bigger because your computer needs to deal with more things to process. The same happens with Three.js. So when you are doing post-processing, you are rendering the scene and then adding another thing that is being rendered at the same time. So if you add 4, 5, 10 steps of post-processing, 10 passes on post-processing, you get some loss on like some performance lose. But I could manage in a way that I could make it work, and also being beautiful. For example, if you guys notice, from the first thing that you enter on the scene, you don't have post-processing. So when the camera animates until it hits the heel of the first camera view, you don't see any post-processing. You don't see any depth of field. I only enable depth of field, and I make a transition, like a seamless transition between the no Three.js post-processing and the post-processing one after the camera animation happens. And why? Because if I try to animate from the beginning, the camera animation with the post-processing, you can see the frame rate dropping because it is too much to handle. So you have a lot of ways to optimize performance. It only takes time and I would say patient and knowledge, because you need to know where the things live and the options that you have. For example, like I said, for the 3 generation, I only noticed that would be available after I finished Wineland, which I use in another project that I would love to show you guys, but I will not try because I will freeze again. But I will share the link here because it is one project that is using uh, this technique of like doing a lot of trees without them being on the mesh, like on the model. Like the model is very simple and all the trees are generated inside Three.js. With only one tree, I generate like 3,000 trees on the terrain. I will share it here. I guess my computer is also freezing. I shared here on Discord, so if someone can share also on YouTube would be awesome. Like this project is the one that I was mentioning that is creating the trees like on real time using Three.js and not imported meshes. And also, when you guys see this running, you guys will see that the trees have like that movement. Also, the wineland, we have the movements on the trees. Like the movements on the trees, they are not animated on Blender. They are vertex shaders. So this is the tricky. When you have shaders, when you have custom shaders, that thing that I showed on the end of our screen sharing, you can distort images, but you can distort meshes. So everything that Three.js renders is through shaders, but you can gain access to manipulate those renderings and those distortions when you use custom shaders. So there is a custom shader that fakes the wind like movement, and then all the meshes that has tree has this vertex shader distortion applied. It is a very tricky thing to do because you need to basically get the material and inside the material replace the vertex shader with your own custom shader. So you have everything that Three.js is doing with the material plus your things, your distortions. But once you understand what happens, like these days I use almost in anything, like on everything that I do, I ended up using custom shader. Like to make distortions and also to change colors and to manipulate things on Three.js. But the basic ones are really good. Like the basic materials are really good. I hope I answered. Sorry for the long answer.
No, it's fine. Thank you for answering the question. So thank you, sir. Thank you for answering the questions. And hopefully we can do more such streams. So thanks for joining. We can do uh, the second parts in coming weeks.
Perfect. I would love to. Like, maybe you guys need to experiment a little bit more, like, and try Three.js, and then you guys will have more doubts, and then we can do some sections like this, so we can explain how to use and where to optimize and things like that. But thank you very much
Yeah,
for having me too, and I hope you guys have a great week.
yeah, yeah. So I have one last question for it.
Ah,
So I
great.
was thinking, if someone is getting started with the 3GS journey and all these, basic concepts of 3GS, what kind of work he can, do to start practicing, or or what kind of work he can get for after learning this basic concept of 3GS?
Like, you mean how to find inspiration, something like this.
Yes, yes.
Yeah, so what I usually do, like I go for the Awards website or Dribble or Behance, and I start looking for references. So seeing what kind of things are beautiful and could use 3D but is not using. Like, and I would say the powerful of Three.js, like it is not used as much as it could be, because usually the guys who have the ideas, the designers, they don't know about Three.js capabilities. They don't know how to do it. So sometimes they imagine things and they think they are not possible. Like I have a project on my GitHub page, which is Three.js Graces, that I created from a Dribble page. So when I was looking through the Dribble references, I saw this beautiful web page for a museum with three figures, human figures, on a background. And as you move your mouse, the lights reacts to that thing as your mouse were the light. And I was seeing that, I was saying, man, this is beautiful. I can do it. And then I saw the comments, and the comments on the Dribble page were, the developer left the job. So the developer gave up. So, and one of other guys being designers saying, why do you create something that is impossible to code? And then I said, you know what? I will do it to show those guys that is possible, totally possible. And it's not even that difficult. And then I created the project. It is open source on my Three.js, on my GitHub page. So if you guys want to see it, it is there. So that's it. Like you start by seeing thing that you like and you challenge yourself to create. So most of the things that I see these days, I look and I see like I can do it and I cannot do it yet. I know it is possible, but I cannot do it yet. But at least now, if I don't try, I don't know the possibilities. I don't know. Like I got some projects on the past that I saw and I said I can do it, and then in the end, I, it doesn't work the way I expected. The performance, I had a lot of problems, so I had to find other ways to solve the project. So I would say to see references, challenge yourself, and commit yourself to do something at least once a month. This is what I do these days. At least one project, one demo per month, I try to do, because doing demos, it is the best way to learn, and also is the best way to teach others. This is what I'm doing. So like I'm not that experienced on Three.js. I'm using it from a year right now. But the amount of things that I already know, I like to share and I like to teach. And this is the beauty of the development community, I would say, because we can help each other. So we have a lot of tutorials, we have a lot of resources, a lot of ways of learning it. The best way I would say is attending to the Bruno Simon course, because the Three.js journey is the really one thing that helped me most to understand how those things happen and how everything works. But for the inspiration, go for design first. See designs, see things that you like, play games, and with those ideas, you generate a concept for you. Usually, I'm cheating these days, like by using Midjourney and all of other AI, because when you go there and you say, imagine, for example, like I did last week, imagine a pinball machine with a graveyard theme, something that I never saw in my life. But I wanted to do this kind of project in Three.js. And then the AI, the Midjourney, give me images that I was like blown away. Like my mind was, how can it's possible? Like the imagination of the AI for that idea is way better than mine. And then now I'm trying to create that one. I'm trying to create the same thing that I saw from the Midjourney, but for a real project using Three.js. So you can do this kind of stuff too. But the important thing is to commit yourself to do something usable in 1 month at least. In the beginning, I was doing like 1 week, but now it needs to be 1 month.
Thank you, sir. Thank you for joining us. And we take this as a lesson, and we learn and start building things in 3GS.
Great, great. Thank you very much for having me, and have a great day, night, and week for you guys. See you.
Yeah, yeah. Thank you, thank you. We'll do it more.
Thank you.
Ciao.
Thank you. Bye.
Ciao, ciao.